if you were given something of this form and it didn't factor, your only way of working a problem up until they came up with the formula was to complete the square. And if you were somebody that had to do this all of the time, you would see, is there a shortcut around it? Because we know that completing the square is a process, and the process is done the same way every single time. So I think that at some point somebody would say, suppose I had the general formula for quadratic, namely that ax squared plus bx plus c equals 0. A, b, and c are real numbers, and I'd follow the process, and it would give me a formula where the coefficient, where a is always the coefficient of x squared, b will always be the coefficient of x, and c will always be the constant. So how do we complete the square? Well, if the coefficient of x squared is not 1, you divide it out to make it 1. So the coefficient of x squared is a, so that you divide everybody by a. So you would get that x squared plus b over ax plus c over a equals 0. The coefficient of x squared is now 1. The second step in completing the square was to put your x's on the left and your numbers on the right. So then you would subtract c over a from both sides. That gives you the minus c over a and your x's on the left-hand side. Step 3 is to complete the square on the x's. So you would take, since b over a is a fraction, you would take 1/2 times b, or 1/2 times the coefficient of x, which is b over a, and then you'd square it. So you'd have b over 2a squared, which would be b squared over 4a squared. Then you would add that to both sides. Now, what I now see is I can't combine the right-hand side until I put it over a common denominator. The common denominator is 4a squared. So c over a, I'm going to multiply by 4a over 4a. That will give me a denominator of 4a squared. So I'm going to have minus 4ac over 4a squared plus b squared over 4a squared. Common denominator of a squared, so I'm going to put the plus in front. So I'm going to have b squared over 4a squared minus 4ac over 4a squared. So that's where I get b squared minus 4ac over 4a squared. So that begins to look a little bit more familiar. The left-hand side I know is a perfect trinomial square. Square root of x squared is x. Center sign is plus. Square root of b squared over 4a squared is b over 2a. Quantity squared is equal to b squared minus 4ac over 4a squared. Next step in the process is to use the square root property to solve. Take the square root of both sides. Don't forget the plus or minus. So I'm going to have x plus b over 2a equals plus or minus the square root of the numerator divided by the square root of the denominator. You have the square root of the numerator, which is b squared minus 4ac. Square root of 4a squared is 2a, so that looks like the left-hand side part of the quadratic formula. And then what you're going to do is subtract b over 2a from both sides, and this should be a minus on that b. So that should be a minus. So I've got a common denominator of 2a, so putting it over a common denominator, I'll have minus b plus or minus the square root of b squared minus 4ac all over 2a, and this is the infamous quadratic formula. It's not magic. I mean, you get people who basically had to do stuff by completing a square over and over and over again. Eventually, they would find a way to do it without having to do it every single time. And that's how they came up with the quadratic formula. And now we're just going to use it. That's kind of nice.